Alright, so here we have the first one. The diagram shows a light incident on a plane mirror. Which row gives the angle of reflection and the name of the line PQ. The line PQ is just the simplest name. It is called normal. So B and D straight away discarded. And then we have to choose the angle of reflection. So the angle of reflection should be the angle between the normal line and the reflected ray, which should be equal to the angle of incidence. So should be the option A, probably the easiest one. Let's take a look at the second. The light is incident on a mirror. The light is reflected from the mirror. The angle between of the incidence I and the angle of reflection is R, which diagram correctly shows I and R. So I and R should be representing the angle of incidence and reflection respectively, and it needs to be ensured that these two angles are always drawn from the normal line. So this one is correct, but this one is incorrect. This one is incorrect, this one is incorrect. This one is correct, this is the angle of incidence, but this is not the angle of reflection. So we have the option C. The diagram shows two divergent rays from an object being reflected from the plane mirror. At what position is the image formed? So this is the object. Image is formed in the same line, in the same direction, but on the opposite side. An object and image should be equidistant from the mirror. So it should be the option B, and that should look something like this. So these two distances should be equal. Above the ground, what is the smallest value of h that allows the customer to see the image of his shoes? So the customer would be able to see the image of his shoes if the midpoint of this one lies on the mirror. That's the shortcut. If the midpoint of this one lies on the mirror. Alright, so for this one, the shortcut is, in order to find the smallest height, you need to divide the total distance between the eyes and the object by 2. So D divided by 2 minus height of the mirror. So D divided by 2. Okay, yes. So this question, we have two variations. One of the question is, you'll find exactly the same thing, but the question would have been, what is the maximum height or maximum value of height that allows the customer to see the image? But this is the second type, in which it says what is the smallest height of h, which means how low we can place the mirror, how low the mirror can be placed so that the customer can see the reflection of his shoes in the mirror. The answer is, if the mirror is placed, if at least one part of the mirror is touching or is placed in the center of his eye and the shoes, which is at 75 centimeter mark. So the mirror needs to be placed at a total distance of 75 centimeter from the ground. So total distance should be 75 meters. centimeters. The height of the mirror was 50 centimeters. Now what is the height h? It would be 75 minus 50, which is 25. Now once again the shortcut is, in order to find the smallest height, whatever this distance is, just take half of it and subtract the height of the mirror from it. Whatever the total distance is, let's say 150, just take half of it. What is half of 150? 75, and subtract the height of mirror from it. For what case? Whenever they ask you for smallest height. The other variation is in which they ask you to find the maximum value of h. For that one, simply find half of this value. So it should be 75. So technically in that case the mirror can be placed as something like this. So this is for the minimum, and for the maximum height it is whatever the distance between the eyes and the object divided by 2. That's it, which in this case would have been 75. Let's move on to the next one. Which characteristics describe the image formed by the plane vertical mirror? So for question number 5, we need to identify the characteristics. Real and inverted, no. That image cannot be projected on a screen, so it is not real. This one, no. Virtual, yes it is virtual. Smaller than the object, no, it is the same size. So it is the option B, virtual and upright, not inverted, which means upright. Okay, question number 6, we need to label the angle of incidence and the angle of reflection. This is the point of incidence. I'll draw the reflected ray. The reflected ray will look something like this, and then we have a normal. So this is a normal over here. Should have been a dotted one, but let's continue with the same. This is the angle of reflection, sorry, angle of incidence. How much? 90. Entire one is 90 minus the upper one, so 50. So the reflection should also be 50. An object is placed in front of a plane mirror. The image produces real crossed out, real crossed out. Virtual and smaller, no. Virtual and same size. So question number 7, we have D. There are certain properties which we need to memorize. Virtual, upright, same size as the object, equidistant. Object and image are equidistant from the mirror. Okay, then we have question number 8. An object O is placed in front of a plane mirror. Which diagram correctly represents the image I formed by the mirror? Okay, so it's not formed on the mirror, rather it should be formed on the opposite side. So 8, C and D cannot be the right options. We need to pick between A and B. Image and object, they are not inverted. Image formed is upright in the same orientation. If the object is pointing upward, the image should also be pointing upward, but B says otherwise. In B, the image is inverted. However, in plane mirror, image is not inverted. Matter of fact, image is upright. So we have A as the right answer for this one. Then we have question number 9. We need to find the angle of incidence and the angle of reflection. So the ray strikes the surface from this side. So angle of incidence should be the angle between the incident ray and the normal, this one. So we need to find this angle mathematically. There are plenty of methods. It's just all mathematics from here. You need to find this angle. And yeah, one of the method is, we know that if this angle is x, then this angle should also be x. Why? Angle of incidence equals the angle of reflection. We know that these two should be same. There is no other possibility. These two angles need to be same. So if the first one is x, just assume this one is x, then the other one should also be the same magnitude. Now what we know is the total angle is 180, and the total angle is made up of x, x and 80. So x plus 80, that should add up to 180, which means 2x equals to 180 minus 80, which is 100, and then x equals to 50 degrees. So this one is 50 degrees, this one is 50 degrees. So plenty of ways. Is basically a question of trigonometry. Whatever method you're comfortable with for mathematics, you can use exactly the same. Let's take a look at the next one. A boy stands beside a girl in front of a large plane mirror. They are both same distance from the mirror as shown. Where does the boy see the girl's image? So boy is standing over here and the girl is standing over here. So this is the mirror. The girl is standing. The image of the girl will be produced in exactly the opposite direction in the same line, but at equal distance. So it should be produced at A. So it is produced at the same, in the same direction, in the same line, and equidistant from the mirror. A ray of light strikes a plane mirror and is reflected. Which pair of angles must be equal in values? This one should be equal to this one, and this one should be equal to this one. So x equals to y and w equals to z. X and y. Yeah, x and y was an option. Could have made it a little bit tricky. But anyway, let's move on to the next one. A student holds a sheet of paper with letters on it facing a plane mirror. The letters on the paper are shown. What does the student see in the mirror? So all we have to do is we need to laterally invert this image. Laterally invert simply means if the object looks like this and then you place it in front of the mirror, from mirror it'll be looking something like this. So this is what we mean by laterally inverted. So vertically, it cannot be vertically inverted. So you see C and D, if you take a look at the letter T, in option C, T is inverted vertically, which doesn't happen. In D, T is inverted vertically. So T from this one now looks like this one. That doesn't happen with the mirror. Image is only horizontally reversed. So for example, if we have F looking like this, at the mirror it will look like this. In option A, F looks exactly the same way, which is impossible. So even by the method of elimination, we have the option B. So this one, flip first, F, O is also flipped, but even the horizontally flipped image of of O would look exactly the same, and even the horizontally flipped image of t would look exactly the same. So for 12, it should be the option B. The diagram shows a ray of light from one point on a lamp striking a plane mirror. The image of the point on the lamp produced by the mirror is. So for number 13, basically we need to tell the characteristic. It should be formed at P on the opposite side and has to be virtual. So at P and virtual. And by the way, how do we complete the diagram? So these two distances are equal, this one and this one, and then we join a line from point of incidence from image to point of incidence, and the back side of it must be the dotted line. So it would look something like this. The diagram shows 4 rays of light from lamp below the surface of some water. What is the critical angle for light in the water? So critical angle is defined because the ray of light enters from a dense medium to less dense medium. As we can see on the diagram, first condition is being satisfied. The second condition is the angle of incidence would be called critical angle. For the angle of incidence, for which the angle of refraction becomes 90°, or it's just another way of saying it. First one you can say either this way: angle of refraction becomes 90, or you can also say the refracted ray becomes bends along the surface, it moves along the surface. You can call it this way. Matter of fact, there's another variation. You can also call it this way: the refracted ray becomes perpendicular to normal. The refracted ray becomes perpendicular to normal. Now, for which angle the refracted ray is becoming parallel to the surface or perpendicular to normal, or the angle of refraction is 90, it is the angle B. By the way, what do we call the angle A? Any guess?
Angle of incidence.
And for A, the angle of incidence, is this angle of incidence less than critical angle or more than critical angle, and how do we know? So this angle of incidence at A is more than critical angle because we can see the total internal reflection taking place. And if we talk about D, the angle of incidence at D is less than critical angle. So just the normal refraction takes place in which the ray of light bends away from normal because the ray of light was moving from denser medium to less dense medium. So D is just some other angle of incidence. There is nothing special regarding the angle D, except for the fact that this angle of incidence is even less than critical angle. So we have just a plain, the simple refraction taking place, and the angle of C would be called as angle of refraction. Okay, question number 15, we have an eye views an object O by reflection in a plane mirror. Which ray diagram is the correct one? So we know that these two rays were initially diverging. Now the rule is, after getting reflected by the plane mirror, the two rays of light should once again be diverging. But what happens over here after reflection? What do you see? Converging, diverging, or parallel? Parallel. So that is not possible. That shouldn't be happening. That does not happen. If the rays of light were initially diverging, after getting hit by the lens, by the plane mirror after reflection, they should still be diverging.
Yes, sir.
So after reflection by the lens, they are converging. Initially they were diverging. Once again, that's a violation. Now let's talk about the option C. What are the rays initially? Diverging. After getting hit by the plane mirror, what are the rays now?
Parallel.
Still diverging. You see, if I extend this one,
तो आई की रेंज से बाहर ही चले गए.
yeah, but they are diverging at least. You see, if I just extend these two, one of the rays in this direction, the other one is in this direction. Tell me now, I've just extended the same rays as it is. Converging or diverging or parallel? Diverging. So in
पैरेलल भी तो है.
no, parallel is if the angle between the rays does not change. For example, like in the option B, if I extend the rays of the option B, check it out. I'll try to extend the rays of option B. So one is exactly in this direction, the other one is exactly in this direction. So what's happening to these two? These are parallel, but the ones in the option C, these are not parallel. They are moving away from each other. So the rule is, whatever happens, whatever is going on with the incident rays, if the incident rays are initially converging, after reflection they should still be converging. So for the question number 16, what do we have? A diagram shows a child who is using a periscope to look at the objects on the other side of the wall. Which diagram shows the correct ray of light from the object? Okay, should be an easy one. So if you remember the diagram of periscope, the easiest thing, the rays enter and exit the periscope perpendicular, like this, perpendicularly. So from the object towards the eye. Alright, they enter and exit in, you can say, straight line. So from the object, the ray should have been incident in this direction, which therefore it means option A is incorrect. If we take a look at the option B, we have the same situation. Matter of fact, the very direction of the rays. The rays are always towards the eye, not away from the eye. So B can be eliminated straight away. D can be eliminated because the direction of the ray of light is incorrect. They should be pointing towards the eye, not away from the eye. Now this angle would also be 45. So the angle of reflection for total internal reflection, angle of reflection would also be 45. You see, this one is also 45 and the total angle is 90. So it's exactly the same as the ray diagram image or the ray diagram of periscope. It's always like that.